So the first part that we're going to cover is the reciprocal function here, which is basically now if I take, let's say, for example, x, you map as f of x, original function. Now the new mapping is x against 1 upon fx. This is called as reciprocal function. Now, logically speaking, if we look at this here, for example, let's say this x and y, f of x is your y value, and then you have 1 over y. So there are certain set of rules that we follow here. Now, for example, when I take x, for example, x is 1, y is 0, and 1 over 0 is actually undefined. So now wherever you get like when you say y is 0, it means that wherever a function is actually having a root, now that's the position where y is 0. So these are the points where y is 0. So at that point, you can see that the reciprocal function tends to infinity. It means that, so wherever you have got the function y is 0, or you got the roots turn into the vertical asymptote. So that's the first rule. So now when I draw this here, what I can say is that, okay, roots become the vertical asymptote. So I can just draw it with, let's say, this color. So this is the vertical asymptote. So you got to have three vertical asymptote basically here. Number two is, if I've got, let's say, any particular point, for example, let's say x is, when I take 5, and for example, y is, let's say, 1,000. Now, when y is 1,000, reciprocal of 1,000 is basically a small number, which is like 0.001. And so what happens is that if your y value is real big, if your function actually goes to infinity, reciprocal will slowly approach to 0. That's a clear indicator. Even if it goes into the negative side, if it function goes to negative side of infinity, I mean, for the negative x value, here the reciprocal will slowly approach to 0. Now, if it is like, if on this x-axis, something like here, if your function is like going downwards towards negative infinity, even reciprocal will approach to 0. If it is like this here, for example, going towards the negative x side and going downwards along the y value, this is going towards a negative infinity. And if you take reciprocal of negative infinity y value, that will be close to 0. Obviously, it'll be something like this. So just general shapes you can remember so that you have just quick like sketching skill is first one that I can recommend is that you basically take as if the function is increasing to the right, it decreases reciprocal will be asymptotic to x-axis. Similarly, if it is increasing towards the left, its asymptote will be the x-axis. If it is increasing downwards, asymptote will be x-axis. So in all these cases, the values approach to 0 and vice versa. So that's your rule number 2. Now, rule number 3 is that if I look at the function is like, let's say for some value, for example, I take x is -4, and for that y value is -1. So -1 reciprocal is going to be -1 itself. So 1 over -1, that's -1. Let's say for -3, I have my y value as 1. So if you have function as 1 over 1, that's 1. So basically, these are also referred as the invariant points, or these are also called as along these values, the expression or the x and y value, I mean, the y value of the function does not change. So basically, wherever you have y equals to 1 function, now let's say if there is a function that has got y value as 1 here, this point will not remain the same. It will be also on the original as well as on the reciprocal function. Now, this takes us to a very interesting rule that function and its reciprocal, if I want to find out where do they intersect, if at all. So if I equate function's reciprocal, you notice that the function square is 1, so you get function is plus minus 1. So whenever your function actually intersects along y equals to 1, so if it is y equals to 1, and the function is reciprocal will always intersect along y equals to 1 and -1, if at all. So let's say here, if I have this point is, let's say 1 itself, maximum is 1 here, and this is, let's say, -1. Now the function and its reciprocal, they'll meet along this. Another rule is that if you have a minimum point, it will be becoming like a maximum point. So if it is minimum, it is going to become maximum. If it is a maximum, it is going to become a minimum. If you've got a function as a horizontal asymptote at y equals to a, its reciprocal will have horizontal asymptote at y equals to 1 over a. So these all things will become clear once you take a proper example. So let's just take one example out here. So the first thing that I'll take very simple function is, let's say y equals to uh, 1 over x square minus 4. Suppose I wanted to sketch this graph without using calculator. So what I do is, let's say if I have first, what I do is, I'm just going to sketch the original function. So the original function is basically going to cut here at -2 and +2. So I'm just going to first sketch x square minus 4. It's a happy face graph here, so it'll be like this. So this is my original function. Now let's just apply these rules that we just learned. So number one rule is that the roots become vertical asymptote. So the number one is roots are becoming vertical asymptote. So you got two roots here. So number one is this one. So you'll have a vertical asymptote here. So that's your first point. Next point is that if the function has got, let's say, increasing nature here, so do the second stuff here, which is that the function is reciprocal meet along y equals to 1 and -1. So since this point is at -4, you draw y equals to 1 line here. Let's say this y equals to 1, and this is y equals to, let's say, -1. So what this does is that this gives us some idea from where your reciprocal is going to pass. So your function, it's reciprocal. If at all they pass, they'll pass through these points. So now coming back to the third part, which is that if you look at this side, the function as x towards, as we go this side, the function is going towards to infinity. And so reciprocal approach slowly to 0. So following this particular shape. So this side, it is going to be something like this, slowly approaching to 0. Now here, what happened is that if you're going towards the left side here, you notice that this shape is obtained here. So it will slowly approach x-axis. So this is approaching, going towards infinity. This is going towards infinity. So reciprocal slowly approach towards the 0 part. Now third one is that this is here is the turning point, which is like a minima will become like a maxima. So here, if you take -4, reciprocal of -4 is -1/4. So here it is going to be something like downwards. Remember that if your function is negative, its reciprocal will also be negative. So this can't be like this. I mean, something like, I mean, there's no other reasoning because it has to pass through these. There's a turning point here. It has to be maximum. And also this has to be asymptotic to these. Now, if function is negative, these y values are negatives. So that's why its reciprocal is also negative. So in this case, what we have is the first point that you notice that there are going to be three vertical asymptotes actually. So the first one is at here. So this is the first one. And you'll have another vertical asymptote at this point. And then you'll have third one at this point. So this is the vertical asymptotes. Then you got the ones with the y equals to 1 rule. That is the function, its reciprocal will pass through. They'll pass by at y equals to 1 and y equals to -1. So y equals to -1 line if you draw here. So that's the meeting point for these functions. So these are the meeting points you can take. Functions reciprocal. Now when you draw the final graph, now you can see that this shape you notice is it's happening here. So this is going to be something like passing through this and asymptote to x-axis. So here the graph is something like this. In this case, if you see there's a maximum at 1, so there's going to be a minimum at 1 here as well. I mean, y value is 1. And then you have this side, which is going to be that there is a minimum here at -2. So maximum will be -1/2. So this will be -1/2. And it'll pass through this. It'll be like this, something like here. And then you have this side is increasing. So this shape, so general shape is going to be here. So that's how you get the reciprocal function for this question.